Welcome to the wonderful world of astronomy. In this semester, you are going to learn a lot about the heavens, the universe, the things in the universe, and the Earth's place in the universe. But before we get into studying all those things, we're going to have Chapter 1, which is a broad overview of astronomy, an overview of the things you're going to learn this semester. So this video is Chapter 1, A Modern View of the Universe, Part 1, Introduction to the Universe. In ancient times, most cultures believed in a geocentric model of the universe, which means that they believed that the Earth was at the center of the universe. As people looked up since ancient times, they saw that the sun rises in the east and sets in the west. The moon rises in the east and sets in the west, and all the stars come up in the east and go down in the west, night after night, year after year. And it seemed reasonable to assume that all these things up in the heavens move around the Earth. Now we know that that's not true, that the Earth is moving through the universe. It is part of a vast cosmos. When we use the word cosmos, you can think of that as the universe. That the Earth is part of a solar system, that's part of a galaxy, that is one of hundreds of billions, maybe even trillions of galaxies throughout the universe. Let's look at our place in the universe. You can think of your address when someone puts your address on an envelope. You think about usually the way we write an address, the very first thing is your name, and that's very specific, it's individual to you. And then the next thing might be the street number of the building, and that's branching out, getting a little bit outward. And then what street number? Well, then you say what street it's on, such as John Satko, 4114 Tarnywood Drive. So there's the name, then branching out a bit more, the street address, then the street itself. And then we branch out further and we say, where is 4114 Tarnywood Drive? Well, that is actually the house where I grew up in the city of Portsmouth. And where is the city of Portsmouth? It's in the state of Virginia. And then if we're doing international mail, we might want to specify where is the state of Virginia. It's in the USA. So you can think of our cosmic address as branching out further, and you can just imagine, this is getting a bit science fiction, but maybe imagine in the future when there is mail that's still being addressed, but it's going from one part of the universe to the other. And we have to specify the name, the street, the city, the state, the country, and then we have to specify where is that country, the United States. So the cosmic address, you can think of this as where would that science fiction, that letter be sent to? And so we would say, well, it's on planet Earth. And my whole reason for talking about this cosmic address is so that you can get a feel for the hierarchy of where we are in the universe. So we are on planet Earth, and there's the red arrow pointing towards that. But in this futuristic scenario, the postal carrier might not know where is planet Earth. And so we'd have to branch out more and say, where is that? Well, we would say that it is part of a star system. So whenever we talk about the location of a planet, we always want to talk about what star system it's in, meaning what star is it going around. So we are in a star system that goes around the sun. And the sun is one of trillions upon trillions of stars. It's special to us because it's the one in our solar system. And our sun's official name is Sol. Now, normally we get by with calling it, as I will in this class, the sun, but its name is also Sol. And every star has its own star system, the things that are in orbit around it. Often there are planets, there'll be asteroids or comets, and every star system is going to be named after that star. Now, ours is specifically called the solar system. We don't call other star systems the solar system. The solar system is ours. And where is our solar system? Well, it is in a larger structure called a galaxy, and our galaxy is known as the Milky Way galaxy. Now, as I said at the beginning of this video, all of this chapter is just a very broad overview of all of the things we're going to learn this semester. So throughout this semester, we will learn about the things in our solar system. We'll learn about the stars in our galaxy. We'll learn about the galaxies. But here is just the introduction. So the postal carrier wants to know, where is this Milky Way galaxy? Well, galaxies are contained inside clusters or groups, and a cluster is a large grouping of galaxies, sometimes hundreds or thousands of them. The word group is usually reserved for very small clusters, and ours is a group. So ours is called the local group. As far as we know, there are 47 galaxies in it. And these groups or clusters are gravitationally bound to each other in superclusters. And so our local group is in a supercluster known as the supercluster. And you can see in the background, the artistry here, all of these, it looks like webs right here. And this is the linking together of all the superclusters as we look out over the largest scale structure of the universe. And so the superclusters then make up the universe, which is, you can think of it as the sum total of all the matter and energy that exists. Now, as I think about the structure in the universe, it also reminds me of history and our learning of astronomy. So while people have always known that we have lived on the ground, thinking of it as a planet Earth, that it is a round, a sphere, we learned this roughly 2,500 years ago, that the Earth is round, that it's part of a solar system that is these planets moving around the sun. We learned that about 400 years ago. That it's part of a galaxy, which is one of many galaxies. We learned that about 90 years ago. And once we learned that there are many galaxies, we soon learned about clusters and groups and superclusters. As we study astronomy, it's going to be important that we understand some definitions used in astronomy. And as I said before, all of these concepts will come up in great detail later on through the semester. Let's start with learning a few words. A star is a large glowing ball of gas that generates heat and light through nuclear fusion. When you look up in the sky, you see a bunch of bright lights, and we can refer to all those things as stars. However, some of them actually are planets. They're not stars. But this is a star. And by the way, you're looking at a picture of our sun, and our sun is the closest star to us. A planet is a moderately large object that orbits a star. Now, that's a vague phrase, moderately large, but when we study the solar system, starting in chapter 7, we'll see what that means. It orbits a star. There are some very small objects, rocks and balls of ice, that are not as large as planets. So these are large objects that orbit a star. It shines by reflected light. So when you look up in the sky, if there are planets in the night sky, some of the brightest things up there are planets. And it's important to know that even though they look to us to be brighter than the stars, they don't actually emit their own light. They just reflect the sun's light. Planets may be rocky, like the Earth, a firm place to stand. They could be balls of ice. They could be balls of gas. And so they vary in their composition. And we'll talk about those in chapter 7. Here you're looking at two planets in our solar system, Mars and Saturn. There are moons, otherwise known as satellites. Now, a satellite is a general term for something that orbits around something else. Satellites can be artificial or natural. And so the International Space Station, for example, or the GPS satellites, those are artificial satellites. But here I'm talking about natural objects, so we'll call them moons. A moon is an object that orbits a planet, and most of the planets have moons around them. Earth only has one moon, but some of the planets have more than 100 moons. And this is a picture of Ganymede, which is the largest moon in the solar system. It orbits the largest planet, Jupiter. An asteroid is a relatively small and rocky object that orbits a star. So there are millions of asteroids, these rocks that orbit around the sun. A comet is a relatively small and icy object that orbits a star. So think of it as a large ball of ice. Now, in the definition, I said relatively small, and then I said think of it as large. Well, that depends on your perspective. Relatively small relative to planets, but it still could be several miles across in diameter. And this is a picture in the sky of Comet Hale-Bopp. It has two tails coming from it. And in chapter 12, when we talk about asteroids and comets, we'll talk about the nature of those tails. A star system, I introduced this term earlier when I was looking at our cosmic address. It's a star and all the material that orbits it, including the planets and the moons. And our star system is specifically called the solar system. And here you have a diagram from the book. There's the sun and the planets going around it, very small. You can see there's a belt of asteroids out here. Beyond Neptune's orbit is what's called the Kuiper belt. It's a belt of asteroids going around the sun. Thinking about the scale of our solar system, if you think of our solar system just represented by a marble, and you're wondering, where are the stars? How close are the stars? Think of the solar system as a marble. And if you want to think where on this scale would be the next closest star, it would be about 30 meters away. So other stars besides our sun are nowhere near our solar system. And on this scale, if you represent our solar system with a marble, and the next closest star would be 30 meters away, you've got the entire Milky Way galaxy, which has about 100 billion stars in it. And we would have to represent the Milky Way galaxy by being a disk that is 400 miles across. So with our solar system, which we've only sent a few spacecraft to the edge, what we consider the edge of our solar system, and that takes travel of more than 10 years to get to the edge of our solar system. And yet, if you represent that distance by a marble, our galaxy 400 miles across. So it is a very, very large galaxy. And then within our galaxy and other galaxies, we see nebulae. Now, a nebula, that actually is the Latin word for cloud. It's an interstellar cloud of gas and or dust. And it is the gas or dust that is, sometimes it's emitting its own light, sometimes it's reflecting starlight that gives all these beautiful colors. Now, this term I used in the definition, interstellar, inter means between and stellar means stars. So that just means it's between the stars. A galaxy, think of it as an island of stars in space. They are gravitationally bound to each other, so they're all held together by gravity and orbiting a common center. And here are two pictures of galaxies. This one on the left is the Andromeda galaxy, and it's got a disk structure, much like the Milky Way galaxy. By the way, lower and to the right is a little companion galaxy that's in orbit around it. And to the right is what's called an irregular galaxy. It doesn't have the nice symmetric disk shape, but these are both galaxies. And the universe is the sum total of all matter and energy. That is everything that is within and between all galaxies. We have to choose our words carefully when we define the universe. Sometimes people define it as everything. And that's actually not a good definition. It gets a little tricky. The job of science is to discover the universe, the workings of the universe, the things in the universe. If there are things outside of our universe, then by definition, science is not equipped to discover those things, to talk about those things. So when you talk about things that are outside of the universe, you're getting out of the realm of science and into the realm of philosophy and theology. But in this class, when we talk about the universe, it's going to be everything that is within the universe, and that sounded very circular reasoning, but it's all the matter and energy. And as we go on through the semester, we will discuss the philosophy behind that definition. That is the end of part 1 of chapter 1, the introduction to the universe. Have a great day.